This module will actively demonstrate the various methods that Claroty uses to collect data, with intent to build databases on hardware asset characteristics and behavioral baselines regarding assets and their connected networks, and incorporate that data into a CTD installation. At all stages of this module, I'll be using the Claroty demo system to demonstrate how the relevant features work. Before demonstrating the relevant features using the Claroty demo system, let's compare the four main data gathering methods used by Claroty OT cybersecurity solutions. Remember that passive detection, active detection, and AppDB are all aspects of the continuous threat detection, or CTD, solution. By contrast, Claroty Edge is a separate software solution with a separate licensing structure. Its purpose is to gather asset metadata that can be used by CTD. Passive detection is the most frequently used data collection method in most cases where CTD is deployed, and it is also the easiest one to implement. Passive detection is non-intrusive and therefore risk-free because it gathers traffic but does not introduce any. It also allows real-time detection of events, behavioral anomalies, and threats as they occur. A disadvantage of passive is that although passive detection continuously dissects incoming data, it cannot show device status changes on demand, meaning that you have to wait for the relevant devices to communicate before information on them can be gathered. Compared to passive detection, active detection can gather information of higher detail and can gather that information on demand. The disadvantage of active detection is that it is intrusive, meaning that it introduces additional traffic into a network environment that may or may not be fault tolerant. Therefore, some technical knowledge is needed to safely use this approach. AppDB is an add-on to CTD. It works by extracting device data from device project files. Project files contain configuration settings that govern the actions PLCs take within a production environment. The AppDB solution is particularly useful in cases where device information is hard to get. For instance, if a CTD server or a CTD sensor cannot get data from a segment of your network due to the network design. Edge is a software-based data probe that gathers detailed information from the asset inventory from the level of the Windows-based host machines that are part of the network. When this information is gathered, Edge relays the information to an upstream CTD site for aggregation. CTD's default data gathering method is passive detection. However, passive cannot gather all asset metadata under all circumstances. That's why Claroty has developed other data gathering solutions like active detection, AppDB, and Edge. So, with a basic set of asset metadata gathered using passive detection, that data set will almost always benefit from being enriched. We can do this by configuring active detection and, if we have it installed, AppDB. To configure AppDB, we go to System Settings, then Data Sources, then AppDB. AppDB learns asset information by parsing the configuration files of those assets. So we start by choosing the network the learned assets will be assigned to. The next thing you'll need to do is upload one or more project files that originate from your assets. I don't have a PLC project file to upload, but the procedure is very easy. All you do is use the Choose File dialog to select a file, then click Start Parsing. The setup for active detection is a bit more complicated. Here you need to know what the correct procedures are and the theory behind what you're actually doing. So before we start on the procedure, let me lay out some theory. Keeping in mind that active detection does have some potential risks, it's important to be aware of the relevant safe practices. Claroty applies what is called a safe active approach by dividing the active detection process into tasks and queries. Tasks actively scan your network to detect assets using simple detection methods. Queries involve polling the network assets using the same language as the device vendor uses. By separating these two aspects, Claroty's approach ensures that while a network scan is happening, hardware assets will not be subjected to incompatible query methods. As an example, if you perform a ping sweep, you don't want to use a Rockwell query method on every device in the network, because not every device will necessarily be a Rockwell device. Claroty uses query methods that are identical to those the third-party vendors themselves use. Tasks are broken down further into discovery and identification of devices. Let's say, for example, that you know you have assets in your network, but you don't know what those assets are. So we need to start by finding out what assets are out there. To do that, we run a discovery. This means we gather information on what devices are part of the current network. Once you've identified the relevant devices, it's possible to run a device query. We'll start by clicking Tasks, then the plus symbol, then Discovery. Once you've chosen a discovery method, you configure it by including the IP range and all other needed parameters. Next, you'll run the discovery task. CTD will identify the specific devices that are being searched for. When the relevant devices have been identified, they will be listed in the Assets table in the Visibility section. At this point, you're ready to configure a query. Queries are configured according to the type of device that you specified a search for by CTD during the discovery. Let's say I want to start a Rockwell device query. First, I click plus to open the dialog. Next, I'll type a name. If you click the Advanced switch, the drop-downs may show more discovery options, depending on the query type. Let's select a query type and subtype. Lower down the dialog, you'll see a notification of how intrusive the query is. In this case, a basic query has a low intrusiveness level, but an advanced one has a much higher intrusiveness level. Click Create to create the query. Once the query has been created, it is listed in the Active Detection Queries table. Within CTD, queries are run automatically. As the queries are run, the Assets page will start being populated with new assets and detailed information on them. If assets are already in the system and queries are assigned to them, those assets will be queried again to detect any change in asset state or information. Any change of this kind triggers an alert within CTD. Now let's have a look at Claroty's fourth data gathering method, Claroty Edge. Edge is a software-based data probe that gathers detailed asset information from the Windows-based host machines in the network, then relays that information to an upstream CTD site. Edge allows you details of the full asset inventory and in-depth visibility into the network, but its main advantage is it's extremely fast. Asset data acquisition that might otherwise take 2 weeks or more can be done in around a day, which really helps from an implementation time perspective. Also, all the hidden costs of the deployment project are now no longer a factor. Remember though, Edge is a separate solution with separate licensing requirements, so it has to be purchased separately from CTD. If you have ever been involved with CTD deployment projects, you'll know that sometimes it can be a bit hard to identify the correct span tapping points. With Edge, that aspect is irrelevant. Edge runs itself and provides you with full asset visibility within a matter of minutes. In that way, it also covers many of the hidden costs of a deployment project. Hidden costs are always a problem in this particular situation. Things like configuring the network, the need to have third parties available, the need to involve the IT team. Also, there is a possibility of things going wrong, with the risk of the project being delayed by weeks. Edge removes these risks because it immediately provides you with the needed visibility. The Claroty platform is a concept that consists of the 3 software-based solutions we offer, based on our 4 main pillars of value, that is, reveal, protect, detect, and connect. In that context, visibility refers to being able to see everything you have in your network. As we know, everything you can't see, you can't protect. Visibility covers things like asset data, network connectivity, network hygiene, the quantity and type of transmissions through your network, the numbers of lost packets, the traffic volumes, and the bandwidth being used in the network. As far as developing industrial cybersecurity solutions goes, Claroty usually sticks pretty strictly to operational technology. But Claroty also monitors market trends and developments, and our support for areas like IoT, industrial IoT, smart buildings, electrical grids, and Industry 4.0 is pretty comprehensive and growing all the time. Each of our customers utilize our products in many different ways by asking themselves, so why do I need this visibility? How can I optimize my processes? And How do I monitor my OT life cycles and make sure they're working in the best ways they can? Which is quite natural. The ultimate point of cybersecurity is to maximize productivity by minimizing instability. Let's see what the CTD Edge integration looks like within the CTD demo environment and the value it is capable of offering. Notice that this CTD installation is clean, with no asset data recorded on it. It's also set in training mode. If I open the asset list view, I currently have no hardware assets listed. If I open the Risk and Vulnerabilities Insights view, I have no insights. No assets mean no insights have been recorded. Opening the Risk and Vulnerabilities Overview, the hygiene score will be 100%. No assets mean no points of failure. Now I'm going to run Edge within the CTD environment. To do this, I've connected to a Windows-based endpoint workstation within the site whose assets I want information on. This is the Windows-based engineering workstation that I'm currently remotely connected to using SRA. All these engineering workstations at all of these sites have Edge installed on them. Going back to the demo, you can see that I have the Edge component available on the workstation. Now, all I need to do is run it. Remember, when I run Edge, the asset discovery will be taking place through a remote connection, and it takes a few minutes at most. When it is launched, Edge shows this screen. Edge is basically asking me what it wants me to do. Now I need to decide what I want to capture. In the host discovery section, it asks if I'd like to collect configuration information from the local Edge host, that being the engineering workstation that Edge is running on. If I want, I can also immediately add custom attributes to the local host. Also, when Edge asks identify configured ICS devices, it's asking if I wanted to extract the project files from all connected ICS devices. The next section deals with local network discovery. What Edge is asking is whether you want to run queries on the engineering workstation's neighboring devices, that is, devices sharing the same broadcast domain. The option is enabled by default. It's a question of what devices you'd like to discover. You can run a device discovery using IT, OT, and IoT protocol broadcasts. You can run a subnet identification using ICMP, and you can also discover IT, OT, and IoT devices directly. There is an important question to ask here. What's the difference between broadcast discovery and direct discovery? Broadcast discovery is quite similar to something like a ping sweep. Edge sends a broadcast message to all device types that I've ticked. Then it listens for basic data that those devices have returned. This process is easy. Edge does the discovery in a granular way, meaning it's been designed to avoid compromising network reliability. So I'll leave all of the boxes checked to run all queries. Direct discovery is a bit more comprehensive. Based on what devices were discovered during the broadcast discovery, CTD will initiate a device-specific query for each device type that was discovered. So we could say that the discovery has two phases. Broadcast discovery asks what device types are out there, and direct discovery counts the number of devices of each type. Also, I've said before that these queries are type-specific. So let's say I want to run a Schneider query. That query will only target Schneider machines. It won't run on, for example, Windows-based machines or on Rockwell PLCs, because neither of those types are built to handle Schneider queries. Now that I've defined the parameters of the discovery, I can start the next step. Here, CTD asks what I want to do with the data from the discovery. My choice here depends on whether or not I have connectivity between the CTD server and the machine from which the discovery is being run. If I know that the CTD server, wherever it is located, is reachable from the machine running the discovery, I can send the data directly to CTD. If there is no connectivity between this machine and the CTD server, I can save the discovery data file to the machine from which the discovery is being run, then manually upload it to the CTD server. In this case, we know that there is connectivity, so we'll send the file directly to CTD. To do that, I need to enter the IP address of the relevant CTD machine. Next, I need to enter the access credentials for the CTD machine, then verify them. When the credentials are verified, I know that the CTD machine is reachable. So now I'll agree to the license terms and run the query. From here, the workstation runs the query. This process normally takes around 5 to 10 minutes at most, depending on the connectivity status of the machine you might be using. Before we wait for Edge to complete its work, let's take a quick stop back at the CTD machine. Notice that CTD is completely empty. The asset count is 0, and no assets are listed in any category. There is nothing in this environment because no discovery data has been forwarded to CTD from Edge as yet. For this video, we've sped up the device discovery period. In an actual environment, Edge would discover all local assets within 5 to 10 minutes. Now that the discovery is finished, let's look at the results. The output from our machine has now been sent to the instance of CTD we're currently looking at. So let's see what results Edge has given us. Remember, this machine was previously completely empty, with no asset data at all. Looking at the dashboard, I now have a hygiene score reading and asset information. All these devices would have been identified in around 10 minutes at most. Let me use that time frame to give you a contrast. You could run Edge, walk away from your terminal for a quick coffee break, and Edge would have completed its work by the time you got back. Compare that with possibly needing to have CTD in training mode for a week or longer. Here in the visibility overview, we can see that we already have assets listed. If I go to CTD's assets list, we'll see the volume of information we can gather just from using Edge and the speed with which we can do it. The chemical plant listing refers to a PLC controlling floor level operations at a chemical plant. This level of detail was gathered in around 10 minutes. We have the full complement of device metadata here with no missing entries. The serial number of the device, the model, the device's risk level, its host name, its virtual zone, and everything else that's relevant about it. Going to device information, we've captured information on all the PLC's rack slots. Going to risks and vulnerabilities, we can see that Edge has done all of the vulnerability management work for us. Because Edge captures device metadata, it can refer to separate databases, compare attributes, and tell us whether there are any known vulnerabilities associated with the devices. We've also identified that this PLC has multiple network interfaces. This particular piece of information doesn't necessarily constitute a CVE, but it's an aspect of the device that the customer would want to be aware of. Notice that the threat detection section is empty. Threat detection is not an Edge function. If the customer needs this, it would be provided by CTD's passive detection function. Network analytics is also not covered by Edge, because Edge only targets endpoint devices. Again, passive detection is the function we'd need to cover this. Going to communication, Edge does deliver information on communication policy schemas, so it will show us which devices can communicate with which other devices and using which protocols. So, what we've seen here is an example of how Edge can contribute a very great deal of network visibility in not much time. You'll also notice that the threat detection overview on the dashboard is rather empty. Again, Edge doesn't capture traffic in real time, so it doesn't alert on anomalies. Also, notice that the only events that have been captured are asset information change events. Again, Edge isn't designed to log system events, but passive detection is. Edge is strictly designed to gather and relay device information, so you can't regard it as a strict replacement for any part of CTD. Rather, Edge and passive detection are meant to complement one another. When that happens, you get the benefits of a full and fast deployment, together with a real-time monitoring solution that alerts on the slightest changes within your network. With that, we conclude the section on CTD's data collection methods, and thank you for your time.